Hello guys, I'm Guru Prasad. Today we are going to explain about some of the most important topic related to ADA, that is analysis and design of algorithm. That is the topics are the very much important time and space complexity. So let's begin the video. Let's start with the introduction. Time and space complexity plays a crucial role in analyzing and designing the algorithms. Understanding these complexities helps in evaluating the efficiency and performance of the algorithms. So this presentation will be delved into the importance of the time and space complexity of the algorithm analysis and the design. So the first question will arise in our mind is, what is time complexity? The time complexity refers to amount of time an algorithm takes to complete a function of input size. That means the time taken for the algorithm to complete its task based on the input size. So it helps in understanding how the algorithms are running. Time grows with the size of the output or the size of the input. Time complexity is expressed using big O notation, indicating the worst case scenario. It is the symptomatic notation. So there are so many types of the time complexity. There are major three complexity types are constant time complexity, linear time complexity, and a logarithmic time complexity. First, we will move on to the constant time complexity. It is represented as a O of 1. The algorithm's running time remains constant regardless of the input size. So next, move on to the linear time complexity. Its representation is O of n. O means that is big O notation. The running time increases linearly with the input size. So next, move on to the logarithmic time complexity. That means O of log of n. Next, the running time grows logarithmically with the input size. So linear time complexity and logarithmic time complexity, it is based on the input size. So next, move on to the factors influencing the time complexity. The number of input element greatly impact the time complexity. The algorithm structure, such as loops, recursive calls, it will affect how time complexity is determined. So the efficiency of the operations performed within the algorithm also plays a major role in the complexity analysis. So next, move on to the space complexity. That is, what is space complexity? In the time complexity, we have three types. That is big O notation, big omega notation, and as well as big theta notation. So those notations are very much used while finding the time complexities, which is quadratic, log, and linear, logarithmic, all those lines. So next, move on to the space complexity. One of the most important topic related to the analysis of the algorithms. Space complexity refers to the amount of memory space of an algorithm requires to run as a function of an input size. So memory space is very much important in the space complexity. So it helps in evaluating how efficiently the algorithm utilizes the memory or the memory resources. So the space complexity is also expressed as a using the big O notation, similar to the time complexity. So next, move on to the types of space complexity. There are three types: constant space complexity, linear space complexity, as well as quadratic space complexity. The algorithm memory usage remains the constant regardless the input size, that is constant space complexity, same as the time complexity. So the linear space complexity is the memory usage increases linearly with the help of or with respect to the input size. Next, quadratic space complexity, which the memory usage grows quadratically within the input size. These are all the three types of the space complexity. That is O n factorial, 2 raised to n, x cube, x square, n log n, O n, that is linear, log n, logarithmic, and O of 1, that is constant. So this is with respect to the input size as well as the CPU operations of the time complexity. Next, move on to the factors influencing the space complexity. The data structures used within the algorithm impact its space complexity. The number and the size of the variables and arrays maintained by the algorithm affect space complexity. Recursive calls and auxiliary space required for the function calls also contributed to the algorithm space complexity. Next, most importance or the importance of the analyzing the time complexity. Analyzing the time complexity helps in the understanding how an algorithm will perform in varying input size. It will base the algorithm analysis or the analysis of the algorithm with respect to the complexities. It will based on some of the factors. That is, first of all, it is depends on the input size, and it will depends on the basic operation performed, and it will depends on the equality of the input size with respect to the basic operation. So it allows for the comparing the different algorithm to choose the most efficient one for the specific problem. Next, optimizing the time complexity can lead to faster and more scalable algorithms. Next, importance of the analyzing of the space complexity. Analyzing the space complexity is the crucial for the ensuring the efficient memory usage in the algorithms. It helps in the optimizing the memory resources and avoiding memory related to the issues such as out of an errors or out of memory errors. Consideration of the space complexity is essential in the designing algorithm for the resource constrained environments. Next, we will move on to the balancing of the time and space complexities. There is often of the trade-off between the time and space complexity in the algorithm design. Optimizing one may lead to an increase in the another, requiring for the careful consideration based on the specific requirements. Balancing the time and space complexity is the essential for the designing the algorithms that are both efficient and both are effective. So the strategies for the improving the time complexity is utilizing the efficient data structures such as hash tables and a binary search trees can improve the time complexities. Implementing the algorithms with a lower time complexity classes such as O of log of n instead of O of n square. O of n square, which it will reflect as a quadratic, can enhance the performance. Next, employing the dynamic programming and memorizing techniques and can optimize the time complexity for certain problems. So next, the strategies for the improving the space complexities. Choosing the appropriate data structure that minimize the memory usage, such as linked lists or the arrays, can improve the space complexity. Linked list or arrays, it will improve the space complexity because the memory will be utilized fully. So the implementing the algorithms can be require less auxiliary space or the recursive call can reduce the space complexity. Utilizing in the place algorithm that modify input data instead of creating the additional data structures can optimize the space complexity. Next, the common pitfalls in the time complexity analysis. Ignoring the worst case scenarios can lead to understanding the algorithm's time complexities. Focusing solely on the theoretical analysis without considering the practical implementation factors can result in the inaccuracies. Overlooking the impact of an input size growth on algorithm's running time can lead to inefficiencies. So the case time complexity of the quadratic equation will be given below that or given in the screen, that is uh, O of n of square. There are 11, 12, 13, 14, 15, 16, 17, 18. There are a lot of array of elements. So it will be worst case of the time complexity, which is based on the common pitfall. Next, we'll move on to the common pitfall in the space complexity. Neglecting the memory usage of the auxiliary data structure or the function call can lead to inaccuracies in the space complexity analysis. Failing to account for the impact of the input size of the memory requirement can be result in inefficient space utilization. Ignoring the trade-off between the time and the space complexity when optimizing algorithms can be lead to suboptimal solutions. Next, move on to the final conclusion of the time and space complexities. Time and space complexities are the vital aspects of the algorithm's analysis and the design. Understanding these complexities helps in evaluating and optimizing the efficiency of the algorithms. By considering both time and space complexity, developers can create algorithms that are both fast and memory efficient. So this is all about the time complexity and the space complexity, which is present in analysis and the design of an algorithms. So I hope you guys enjoy this video. Please utilize the this material. That means the space and time complexity are very much important to solve some of the algorithmic problems. So we have to write the algorithm which is based on the problem conditions or the problem statements. So by using the time and space complexity, we can solve any of the problem, which is by analyzing and designing an algorithm. So this is all about this video. So please like, share, subscribe the video, share as much as possible. So thank you all.